Hi, I'm Vahra. Now it's my turn to explain about central tendency. Central tendency is the first aspect of a test to consider. Central tendency itself describes the most typical behavior of a group. There are four statistics are used for estimating central tendency: the mean, the mode, the median, and the midpoint. Let's break it down one by one. The first one is the mean. The mean is probably the single most important indicator of central tendency. The mean is virtually the same as the arithmetic average that most teachers calculate in grading classroom tests. It represents the average value of the data set. The mean is symbolized in writing by x bar. We use this formula to define the mean, where x bar is mean, x stands for score, n stands for number of scores, and c sum or add. The formula simply says to get the mean, we sum or add up the scores and we divide them by the number of scores. So here is the example. These steps are shown in this example. To find the mean in this example, First, we sum or add up the scores, and then we find the number of scores, and we divide the sum of the scores by the number of scores. So, the mean in this example in the table 4.5 would be 69. Well, another indicator of central tendency is the mode. The mode is that score which occurs most frequently. In the previous table, what would the mode be? It would be 69, the only score received by 4 students. No statistical formula is necessary for this straightforward idea. If no number in the list is repeated, then there is no mode for the list. The third indicator is median. The median is that point below which 50% of scores fall and above which 50% fall. Thus, in the set of scores, the median is 71 because 71 has 3 scores above it. There are 100, 99, and 83. And the 3 scores below it, there are 61, 57, and 30. Okay, another example. What is the median for this scores? Well, in such a situation, when there is an even number of scores, the median is taken to be the midway between the 2 middle scores. In this example, the 2 middle scores are 15 and 16. So, the median is 15.5. Does that make sense? If so, what is the median for this scores? Your answer should be 55. Because that is the point halfway between the 2 middle scores, 50 and 60. Now we come to the last indicator of central tendency, that is the midpoint. The midpoint in a set of scores is that point halfway between the high score and the lowest score on a test. To calculate the midpoint, we use this formula. For example, if the lowest score on a test was 30 and the highest was 100, the midpoint would be the halfway between these two scores. We use the previous formula. The first, we identify the high and low scores. There are 130 here. And then we add the low scores to the high one. 100 plus 30 equal 130. And last, we divide the result by 2, like this. Okay, now we are going to move on to the next step is to consider, that is dispersion, or how the individual performances vary from the central tendency. There are 3 indicators of dispersion that commonly used for describing distribution of the test: the range, the standard deviation, and the variance. The range. Most teachers are already familiar with the concept of range from the test that they have given in class. Simply put, The range is the number of points between the highest score on a measure and the lowest score plus 1. 1 is added because the range should include the score at both ends. Thus, in this example, in table 4.5 previously, where the highest score is 77 and the lowest is 61, the range is 70 points, where we got from 77 minus 61 plus 1 equal 11. The range provides some idea of how individuals vary from the central tendency. The range is usually reported as one indicator of dispersion and should be interpreted by test score users as just what it is, the number of points between the highest and lowest scores on a test, including both of them. The next is standard deviation. The standard deviation is generally considered a stronger estimate of the dispersion of scores. Brown, 1988, defines the standard deviation as a sort of average of the differences of all scores from the mean. Now, let's take a look at this table to make this clear. Remember that the mean in the table previously was 69. We used the same scores and the mean. These tables illustrate the steps required to calculate the standard deviation. The first thing that we should do, A, we line up each score with the mean. And B, we subtract the mean from each score. Then, each of the differences from the mean is squared. And D, the squared values are added up. And E, the appropriate values can be inserted into the formula. In this example, the result after taking the square root is 3.87. In short, the standard deviation is a sort of average of the differences of all scores from the mean. These differences from the mean are often called deviation from the mean. Hence, the label is standard deviation. Keep in mind that the standard deviation is a good indicator of the dispersion of a set of test scores around the mean. The standard deviation is usually better than the range because it is the result of an averaging process. Sometimes, a slightly different formula is used for standard deviation. This version called the N-1 formula, which is only appropriate if the number of students taking the test is less than 30. Okay, now the last indicator of the dispersion is variance. The variance is another descriptive statistic for dispersion. As indicated by its symbols, the test variance is equal to the squared value of the standard deviation. Thus, the formula for the test variance looks very much like the one for the standard deviation, except that both sides of the equation are squared. Hence, the test variance can easily be defined with reference to this formula as the average of the squared differences of student scores from the mean. The test variance can also be defined as the square of standard deviation. Next, how should descriptive test statistic be displayed? The next step is to consider is how to present the statistic once they are calculated. Most often, the purpose is to summarize the information so that everyone involved can better understand how well the test worked or how well the students performed on it. In most cases, descriptive test statistics are displayed in the form of the table. Here is the example. The table shows very real tests result from a retyped version of the English Language Institute placement test. The next is this table. This table displays the same information with the column labels changed to row labels and vice versa. Many other possible variations exist, and the form that test developer chose to use will depend on their purposes in displaying the statistic. Okay, that's all from my explanation. We go back to the moderator. Thank you.